driving up the level of the sea over the course of the last 100 years or so. And at the same time, we can see a reduction in mean snow cover in the northern hemisphere, which is on that third graph down there, which matches very closely with the increase in mean sea level. Water that used to be frozen on landmass is now melted and in the ocean. And this is the result of global climate change. Those time series that I just showed you for global mean temperature and global mean sea level are averaged over the entire planet. And there's a common misconception about global climate change that these mean effects, whether it's temperature or sea level, will increase worldwide at an even rate. You know, it will get warmer everywhere to the same degree. That's not actually the case. Let's take a look at a figure from the IPCC that depicts what observed climate change looked like over the past 25 years or so. So on this figure, you'll see the global mean temperature variation across the world between 1979 and 2005. On the left side there you see a map of these temperatures at the surface, and on the right in the troposphere, which is higher up in the atmosphere. That's of interest to climate change modelers, but from our perspective the most important figure is the one on the left, the ground temperatures, which we actually experience on the ground. And you can see that there is a modeled effect to the map. There is a general heating across the entire planet, but it's not perfectly even, concentrated to a really great degree over most of the northern hemisphere, especially Europe and China and parts of the North Pacific. You may be surprised to note that there are parts of the planet that are actually getting colder and have gotten colder over the last 25 years or so, including parts of the ocean and especially Antarctica, which has been getting substantially colder and will continue to do so as we go forward. Now, what I'm adding here is the time series global mean temperature that we looked at the previous slide, but with a few slopes added to it. What we've done here is added a number of lines that show the average slope, which is to say the average rate and increase in temperature over several different time scales, from about 150 years for the red line to 25 years for that yellow line. And the point you can see from this is that the slope of that line, the speed with which the global mean temperature is increasing, is itself increasing through time. The less distance we look farther back in time, the faster we see that the mean temperature has been increasing. That's what gives us that sort of hockey stick shape to this time series. So this is a pretty strong indication that not only is global mean temperature increasing, but it is increasing faster and faster as we go through time. So that's what we've seen so far in terms of increasing temperatures over the course of the past 100 years or so. But what about predictions for the future? That's where really most of the debate is and what we really want to know. What is this going to look like over the next 100 years or so? And before I can get into specific predictions, I need to explain how it is that global climate modelers will arrive at these sorts of predictions. And to do that, I need to describe modeling. And when I say models, what I'm talking about are sophisticated computer models used by numerous research groups to predict future climatic trends using a variety of emission scenarios. And by emission scenario, I mean a number of different possible futures for how much greenhouse gas we as an industrial society emit. Because ultimately, the amount of global climate change that we will endure in the coming century is strongly dependent on how much greenhouse gas we emit into the atmosphere. The consensus predictions of these modeling groups is what's presented in the IPCC 2007. So this is not the result of just a single scientist or even a single group of scientists. It's not the result of a single model run on a single computer at one university in the world. It is the consensus of dozens of research groups using many, many different models, all getting more or less the same results. So there's a great deal of rigor and agreement in the climate change community about these predictions that I'm about to talk about. Now, before we can establish any kind of confidence in these predictions, we need to make sure that these models are accurate, these computer models that basically simulate the global climate. And that's where this figure comes from. What you see here are two shaded regions, pink and blue, which represent the range of predictions given by these various computer models for global mean temperature over the last 100 years. Under a variety, or under two different emission scenarios. The blue region represents a scenario where humans are not emitting any greenhouse gases whatsoever. And you can see that those numbers remain flat, whether it's across the entire globe, over the ocean, or over land. Just very stable temperature. This is if humans weren't burning fossil fuels at any industrial level whatsoever. This is what the models predict, given the concentrations of greenhouse gases at the beginning of the century, but no data after that. This is the prediction that the models have for the 20th century, given no actual data about the 20th century. As far as the models were concerned, it hadn't happened yet, and this was their prediction for what would happen. Then the pink region represents the emission scenario that matches the greenhouse gases that were actually produced by human society over the course of the 20th century. And you can see that there is a definite increase in temperature with time in that scenario. The really important point here is that the black line, which represents the actual measured increase in temperature over the course of the last century, very closely matches that pink region. Now, I want to stress again that the computer models that generated that pink region did not have any actual historical data for temperature in the 20th century. This was a prediction based on some parameters that were input for the beginning of the century and then were extrapolated through time. So what this is telling us is that even with the computer models not having any data about the period they're trying to predict, they can predict it with pretty strong accuracy. And since they could predict the 20th century, given the data that we fed it, we're relatively confident that they will be able to predict the 21st century, given the same sort of information. And that's how we're making predictions into the future. So what we see on this figure are the predicted global mean temperature increases over the course of the next century under a number of different emission scenarios. Specifically, there are 4 emission scenarios on this chart that we're interested in. First, we have this black line, which goes from the left side of the figure to the center. That represents the actual increase in temperature over the last century. This is measured numbers. There's no real uncertainty about this. From the year 2000 to the year 2100, we see 4 colored lines that represent 4 different emission scenarios under the models. The orange line, the lowest one, that's the flattest, represents a scenario where humans froze their carbon emissions in the year 2000. They stopped emitting carbon whatsoever. By carbon, I mean carbon dioxide and methane into the atmosphere. And you can see that the warming trend would continue during the beginning of the 21st century, but would quickly level off and stop increasing significantly because we stopped burning fossil fuels and producing greenhouse gas. This is not actually a reasonably expected scenario. Nobody is suggesting that we could do this, actually just stop burning fuels altogether. What this acts as is a baseline to represent what would climate change do if humans disappeared from the planet tomorrow. And the answer is it would increase slightly and then start to stop, which makes sense. This means that it's anthropocentric climate change. This is human activity that is driving this process. Next up, we have a blue line, which is the B1 scenario. And simply put, the B1 scenario was the expected greenhouse gas emissions over the following century if there was serious international regulation of greenhouse gas emissions. The simplest way to state this would be, you know, the successful signing of the Kyoto Protocol or something similar to that. A serious attempt on the part of national governments to curtail greenhouse gas emissions. And this very optimistic scenario shows a pretty sizable increase in temperature over the course of the 20th century, but beginning to level off at right around 2 degrees Celsius by the end of the century, above the current temperatures now. Before I go further on, I want to help anybody out there who's not comfortable dealing with Celsius, my American friends. A degree Celsius is roughly equivalent to 2 degrees Fahrenheit. So if I say that global mean temperature is increased by 2 degrees Celsius, it's increased by roughly 4 degrees Fahrenheit. So just double the numbers that I'm talking about, and you'll be back in Fahrenheit space, and might have an easier time visualizing it than thinking of these things in terms of Celsius. The next line up is the green line, which is the A1B model, which is an abstract name for an intermediate model. This was the model that the climate change modelers thought was most likely. It represents a small curtailment of greenhouse gas emissions by the world community by using some relatively non-invasive legislation like cap and trade, for instance, or some other regulation that reduces greenhouse gas emissions somewhat, but not to the extent that the Kyoto Protocol was seeking to do at the end of the last century. And you can see that that increases more or less linearly throughout the 21st century, ending at right around 3 degrees Celsius or 6 degrees Fahrenheit by the end of the century. which is a pretty substantial increase in mean temperature. And more importantly, this model indicates that it's going to continue to increase at that rate, into the future. There is no plateauing or leveling off. This is not realistically stopping climate change from occurring. This was the scenario that the climate scientists thought was most likely.